Hi everybody, welcome to the self-check section 10.1 video. Let's look at number one. So number one states weighted alpha is a measure of risk adjusted performance of stocks over a period of a year. A high positive weighted alpha signifies a stock whose price has risen, while a positive weighted alpha indicates an unchanged stock price during the time period. Weighted alpha is used to identify companies with strong upward or downward trends. The weighted alpha for the top 30 stocks of banks in the Northeast and in the West, as identified by NASDAQ on May 24, 2019, are listed below. So here we have Northwest 30 stock banks, sorry, Northeast, and here we have West 30 stocks of banks. So uh, the question that's being asked here, is there a difference in the weighted alpha of the top 30 stock banks in the Northeast and in the West? And we want a 5% significance level. So a couple of things here. When I read that word, is there a difference? To me, what that means is not equal to. And that's going to be our claim, not equal to. We want to know if there's a difference. And Northeast and West. So Northeast would be my mean one, and West would be my mean two. But we could write that out as well. Off to the side, like mean one is Northeast, and mean two is our West. Okay, that means our first population is Northeast and second population is West. So since we have two means and we have a claim, we want to write our hypotheses. So in the step one, our null and alternative, we know from the question, is there a difference? That means that's our claim. So our null and our alternative hypothesis would be mean one does not equal mean two. And that would be my claim. And opposite is our null hypothesis, meaning mean one would equal mean two. Okay, so that is our hypothesis. So a couple of things before we get going. 5% significance level. That means alpha is 0.05. And another thing to observe for this question is we're given a list of data for both populations. We're given Northeast data and West data, 30 each. So what we want to do in this situation is put Northeast data in list one and West data in list two. So you're going to go to your calculator, go to calculate 84 or whatever app you're using, hit edit, and I already went ahead and did it, but you want to list all that data in list one and list two, and you want to make sure you're getting 30 pieces of data each. So double check your work, make sure you put that in, but pause the video, take a minute, and input this list of data for both. Okay, welcome back. So you should have inputted in the list of data for both list one and list two for Northeast and West. Let's go ahead and continue on with our hypothesis test. So step two is our calculator work. So remember, we're using two populations here and we're looking at their means. So we want to use two sample t-test. So let's write that out. Two samp t-test. And what does our calculator say about two SAM t-test? So let's go to our calculator and we want to go to stats, tests, two SAM t-test. Okay, so we have two options, data or stats. Since we're given a list of data that we had to enter in, we're going to choose the data option. So when you're in the data option, make sure you have your list one and list two accurately put down. Frequency is always going to be one. And here's where you choose your inequality. So since our alternative hypothesis was mean one doesn't equal mean two, we're going to choose this not equal to option. Okay. Pooled is always no. And we're going to hit calculate and hit enter. So there we go. We get our test statistic T equals 0.153365 and p-value of 0.878 rounded up to 7. So let's write a couple of things down. So we're going to fill out step 2 and step 3. So step 2, we use the data option. We use list 1, list 2, and the frequencies were just 1 and 1. Our inequality was not equal to, and our pool is always just no. And so when we ran that test, what we got was a test statistic of T equals 0.15 and a p-value of 0.8787. Want to round up to 4 decimals for that p-value. It's a probability. So for our conclusion, what we need to do is compare our p-value want to compare our p-value and our alpha. Which one's bigger, which one's smaller? So our p-value was 0.8787 and our alpha was 0.05. So which is bigger? Well, it looks here that our p-value is going to be bigger. And when our p-value is bigger, we fail to reject the null. Okay, so we came to a conclusion that we failed to reject the null. Let's go ahead and write a final conclusion. So pause the video, try to write your own conclusion, and then compare what we got here. Okay, welcome back. So if you try this out using your conclusion table, we failed to reject the null, and our claim was not equal to, so we had no equality in claim, and we fail to reject the null. So this is a conclusion we should have came up with. There is not sufficient evidence to support the claim that there is a difference in the weighted alpha of the top 30 stocks of banks in the Northeast and in the West. Okay, so last part of this is constructing a confidence interval. So we want to verify our work. We want to verify that we can't really support that there's a difference in the weighted alphas in both banks or in the top 30 banks of the Northeast and in the West. So what we need to do is sort of verify that with a confidence interval. So in a confidence interval, we're given a specific confidence level, but in the question, we're not given a percentage. It's not telling us how much confidence we need to build this interval with. So what we need to do is go ahead and find our confidence level for this confidence interval. So let's go ahead and write that out. So need confidence level. So what we need to do is look at our alternative hypothesis, that inequality. So in our alternative hypothesis, we see that we have a not equal to symbol. So when we have a not equal to symbol for our alpha, that means it counts for both tails of the distribution. So let's write that out. So not equal to means two tails. So what does that mean? What that means is alpha being 0.05 counts for both tails of distribution. So what that means is if I draw a distribution here and I have my two tails, that means that 0.05 counts for both of these tails. So each tail the two tails would need to add up to 0.05. So that means 0.025 is the shaded portion of both tails because they need to add up to two tails. Okay, so if 0.025 and 0.025 are on the ends, that means in the middle, I'm going to have 0.95. So that would be the confidence level I would need. We could also mathematically do that. So remember, confidence level is 1 minus alpha. And since alpha is accounted for 0.05, it'll just be 1 minus 0.05, and that just equals 0.95. So 0.95 is my confidence level. So I can use confidence level and construct a confidence interval now. So here we go, confidence interval. I'll abbreviate it with CI. The CI equals, and for a confidence interval, we need to use 2SAMP T interval. So let's go to our calculator and see what we need to use for that. So 2SAMP T interval, we've got to go to stats, tests, and scroll all the way down. See the option 0, 2SAMP T interval. Still using data. We still have our list ready to go, and we need to change our confidence level to 0.95. Luckily, it's already 0.95 right there, so we don't got to change anything. But we're going to go ahead and hit calculate. Okay, so you see the numbers up top, negative 10.95. Okay, so this is what you should get for your 2SAMP T interval, negative 10.95 to 12.76, round up to 7. Okay, so let's go ahead and write this answer out and also our calculator work. So 2SAMP T interval, we chose a data option. We had to use list 1, list 2. Frequencies were 1 and 1. We had a 0.95 confidence level, and our pooled was no. And so what we obtained was negative 10 point, excuse me, let me go back to negative 10.95 and 12.77. Okay, so negative 10.95 less than mean 1 minus mean 2, their difference to 12.77. So since you could see here that we have a negative number for our lower value, a positive number for our greater value. And so what that means is this includes our confidence interval includes 0. And when our confidence interval includes 0, that means there's no difference. No difference in the means. So what we write as a final conclusion is since the confidence interval does include 0, it appears that there is no difference in the weighted alpha of the top 30 stocks of banks in the Northeast and in the West. Okay, so we found that there's no difference, meaning that the Northeast and in the West, their top 30 stocks are essentially the same. And that definitely verifies what we found in our hypothesis test because we couldn't support a claim that there is a difference, meaning there was no difference in the banks. So our hypothesis test and our confidence interval line up with each other in their explanations and reasoning. So that means our comparison of the two means was successful. So check. So that's it for this video. Thank you for watching, and I'll see you next time. Goodbye.